All right, let's consider this exam type question, which is essentially analyzing a graph showing us solubility curves for different ionic compounds. All right, so our first, I don't know, when you look at these graphs, the first thing I'm going to recommend always is to look at the axes and figure out what you're looking for. So we've got temperature on the x-axis. So as we increase temperature, what happens to the solubility, which is in grams of salt per 100 grams of water? So always make sure that your question is asking you about 100 grams of water, or if it's different, make sure you make that calculation change. So I know you're going to rush on exams, but take a deep breath, look at those axes, make sure you know what you're looking at, and then dive into the question. So our first one here is the solubility of NaCl is blank. So greater than, equal to, less than the solubility of KNO3, potassium nitrate, at 35 degrees Celsius. All right. So this is really just graph interpretation. Can we find the things on the graph and come to the right conclusion? So we've got 35 degrees Celsius. So I'm going to find 35 degrees Celsius. Oh, shoot. And I am still on, I don't want to be on that. I want to be on this. All right. So I think we're back to where I wanted to be. So there's 35. Okay. Now we need to find sodium chloride and potassium nitrate, are those two curves. So potassium nitrate is our green curve here, and I'm going to draw this straight up. There's potassium nitrate, there's NaCl. So at 35 degrees, I could get, let's call it about 35 grams of NaCl to dissolve in 100 grams of water. And then for KNO3, it's much higher, right? And it's more like, I don't know, let's call it 53 in the same amount of water at the same temperature. Okay, so KNO3 is more soluble. All right, so when you go to that drop down, you would select is smaller than. Okay, because I can't dissolve as much NaCl as KNO3 in the same amount of water at the same temperature. So KNO3 has a greater solubility, or I could say that sodium chloride has a smaller solubility. All right, if 30 grams of KClO3 is added to 100 grams of 50 degrees Celsius water, the resulting solution would be, and we have three options here, okay? We have saturated, unsaturated, and supersaturated. Okay, so again, simple graph reading. We got to find 50 degrees Celsius and we need to find our KCl3 line. Okay, so there's 50. Here is our KClO3 right there. That to me looks like, I don't know, 19 or so grams. So I'm going to start adding my KCl3 into my water. Once, at 18 grams, all of it is dissolved. I don't see any solid sitting at the bottom. Once I get past 19 grams, and of course I'm stirring this and I'm making sure, I've got the right setup in lab or whatever. Once I get past 19 grams, I am going to see solid salt begin to accumulate at the bottom because I have hit saturation. I cannot put any more KClO3 into solution. This is now a saturated solution. So under here, so under this line, that is unsaturated. Over this line, that is saturated. And I will see salt at the bottom, like solid salt. At the point, that point right there, oh, that's a terrible arrow. At that point right there on the line, it is saturated, but I don't see any solid yet because I haven't put any more in. But any more, like we're right on the precipice. Like we're teetering between unsaturated and saturated. And I'm going to still call that saturated because I can't put any more in. But technically I could look at that and say, well, there's nothing dissolved at the bottom. I don't know if this is saturated or unsaturated yet. I have to add a little bit more to figure that out. I know that this is not super saturated because I have not done anything crazy like tell you, hey, I heated this solution up to 100 degrees Celsius and then I slowly, carefully let it cool down and didn't disrupt it. You got to do something special to make it super saturated. Just because I'm above that, just because I've added more, doesn't mean that that extra salt has been absorbed or has been dissolved. That's the right word, has been dissolved into solution. It just means that it's sitting at the bottom as a solid. So super saturated, we got to tell you something that like we did something special in lab to make that happen because it's thermodynamically not super stable. It's a metastable. All right, so that is a saturated solution. And then lastly, we have a saturated solution of CaCl2, calcium chloride. It's prepared at 20 degrees Celsius. If we add more calcium chloride to the flask, the concentration of Ca2 plus of calcium cations and chloride anions in the solution will, and then your options are decrease, increase, or stay the same. Okay, so the key here is that we know that this is saturated. I can't put any more ions into solution. So even though I add more of the salt, I am not going to get more ions in the solution. I've already maxed it out. Okay, so I'm not going to increase the concentration. It is going to stay the same. I would see more solid salt accumulate at the bottom of the flask. That's what I would see, but I'm not getting any of that salt into solution, okay, because I've already saturated it.